হ্যাঁ, এইবার শুরু করি।
হ্যাঁ ম্যাম, yes you can start.
ঠিক আছে, কেউ একজন হাত তুলেই রেখেছে।
Yes, there is a participant, Dipendu Kumar Pal. So do you have any question?
No, I think he forgot to I mean, he raised but then forgot.
Yeah.
Or by mistake it will have happened, maybe.
Okay, so session of the very first day. So we found so it's over to you again, ma'am.
So I am audible, na? There is no problem with my voice, or is there any problem? Because from the other side, I cannot hear everyone properly, and there are some disconnections. On my side, maybe the incoming there is a incoming signal problem. But you can hear me properly, right?
Yes, ma'am.
Yes, ma'am. Perfect.
Okay. That's fine. Thank you.
এইসব কথা কে বলেছে? এইসব কে বলেছে? এইসব
আমার দিদুন বাড়ি আছে।
এই টপিকটা বিসিসিআই লিনিয়ার কিউব একটা সিম্পল কিউবের কনসেপ্টটা কিন্তু
Requested to mute yourselves, otherwise not possible.
Dr. Bhattacharya, can you hear me?
Yes, sir. Yes, sir.
You please mute all the participants except madam immediately.
Doing that, but
You please mute all the other participants except ma'am.
Ma'am, I have muted all the participants, and can you please unmute yourself?
please mute yourself. for one. Ma'am?
I was not. I somehow I left this actually.
Yes, ma'am. Now it's okay.
Now,
Okay, ma'am.
I hope I am audible, right?
Yes, yes.
Okay.
Madam, with your permission, can I give an announcement here?
Yes, sure. Why not?
If this is for the participants, if anyone want to ask any question, first please raise your hand, and then we will, from the organizer side, we will unmute you. Right now, all the participants are forced muted, except Madam. If anyone have any question, please raise your hand. We will unmute you. Okay. Thank you, Madam. Please.
Yeah. Okay, so again, I will have to start because I didn't understand that I have been, I have left the presentation. Now I am audible, I hope, right?
Yes, ma'am.
Okay.
Yes, ma'am. You're audible.
So we will talk about cloud architecture and deployment models. And while discussing this, I'll also enter into a new discussion, the age of anything as a service. And after talking about deployment models and service models, anything as a service is a new characteristic of cloud, because we are the cloud providers are now trying to make everything available on cloud as service. So service model, part of services from cloud. It's not possible for me to discuss all the types of services that cloud can provide now, but I will focus one specific type of service which we have attempted from our side, that is sensing as a service. Through this discussion, I will try to explain how a type of service can be provided in the cloud, what are the different things we need to consider, what are the complexities, etc. And I don't know how much time we will get. Based on that, I will talk about resource modeling, resource scheduling for sensing as a service, etc. So this is just an architectural overview of cloud computing. As you can see at the bottom, we have shown the different characteristics. resource pooling is there because everything is considered as a pool of resources from where we can draw some resources, use for our own purpose, and again release whenever our task is over. This type of services can be measured. That means the cloud providers can measure the amount of services. Based on that, the cost model is developed. Elasticity is there. I already talked about elasticity, and on-demand self-service is also there. On top of these essential characteristics, different service models have been developed, like software as a service, platform as a service, and infrastructure as a service. These are the three service models. We will talk about these service models a little later. We also have different different types of clouds, like private cloud, community cloud, and public cloud. Mainly these three types of clouds. And a hybrid cloud can be built taking any of the public or private or community cloud, any one, any two or more. Okay. So what are these deployment models? Private cloud, as we know, only limited access. That means if we build a private cloud in our own within our own institutions, only the people whom we allow to access the cloud will be able to access. So it will have limited access. And the implementation is at customer's premises, and stakeholders of an organization can access it. But server side can be outsourced to a hosting company for maintenance, etc. On the other hand, community cloud is deployed for a particular community. For example, both Microsoft and Google, they provide cloud services for government. So government can deploy a community cloud for the government offices. So this is one example of community cloud. Again, here it is implemented at customer's premises, and server side is outsourced to a hosting company. On the other hand, public cloud, it's not shown here, but public cloud is accessible by anyone who wants to access it. Public cloud is hosted at the data centers which are connected to the internet. So public clouds are normally accessible through the internet. And whenever you access Amazon EC2 or Google Cloud or other Microsoft Azure, etc., then actually you are accessing the public cloud. So we have public cloud, Amazon EC2, Azure and Google App Engine, I already mentioned. Private cloud can be built with Eucalyptus, with Zen hypervisor, Amazon VPC, VMware Cloud Infrastructure Suite. Hybrid cloud can be built with Windows Azure. They have different suites for hybrid cloud. VMware vCloud can also help to build hybrid cloud. So, when we talk about cloud services, so that those were the deployment models, and it depends on the accessibility. That models are different because of the accessibility or access allowed to different groups of users. Coming to the cloud services, there are again different types of service model. The first one is infrastructure as a service, which is provided by Amazon AWS. Sorry. Here, hardware is provided by the basic hardware is provided by the cloud service provider, and middleware and applications will have to be built by either yourself, or maybe you can ask some SaaS provider. I will come to SaaS later. SaaS provider to give you the middleware and application. So here the user can pay to the SaaS provider, and SaaS provider will pay to the cloud provider, or user can directly pay to the cloud provider to get the services. In this case, you don't need to, you don't have to access the application. Rather, you can ask for few CPUs, some storage, some memory, etc., to deploy your own application. That is infrastructure as a service. Whereas, and in fact, when I talked about HPC, I think this type of infrastructure as a service will be very much helpful to HPC users. On the other hand, the second category is platform as a service, where the not just hardware, the middleware is also provided by the cloud provider. And application can be built on your own, or application can be built by the SaaS provider. So you can either pay directly to the cloud provider who is providing hardware and the middleware, the platform as a service, and like Windows Azure, and you can build your own application, or you can ask a SaaS provider to build the application on top of hardware and middleware. And then the software as a service, where everything is built by the cloud provider and user pay directly to the cloud provider to use such type of applications. So when we are talking about HPC, then probably, obviously, as I believe, this IaaS and PaaS, these two will be very much useful. But SaaS is more useful for the users who want a ready-made solution like financial management, risk management, or say data, any kind of data analysis. So who want a ready-made solution can go for SaaS application. Okay. So in case of the difference is shown in this slide as well. So when you have your own machine, the packaged software which is procured by you, starting from networking, storage, servers, virtualization, operating system, middleware, runtime, data, application, everything is managed by you only, or the organization to which you belong. Whereas infrastructure as a service, when it is provided by the cloud provider, this networking, storage, servers, and virtualization, up to this will be managed by the cloud provider company. The rest, that means OS, guest OS, obviously in this case, middleware, runtime, data, and applications, all these will be managed by you or your organization. Okay, so you consider which OS will you want to use, which middleware you will deploy, and the cost of IaaS is much less than the other types of services, obviously, because when we go for platform as a service, then even OS, middleware, runtime will be provided by the cloud providers. So they will obviously charge more for such type of services, whereas this costs much less. Data and application will be managed by you only. The last one, that is software as a service, everything is managed by the vendor and you are only the user. So probably the example which was given by one participant in the earlier during the earlier talk, click to get the service. So probably he was talking about this kind of services where we just click to get some kind of software as a service here. On the other hand, in this case, you will have to write the application, develop the application for your own, as per your own requirement. So these are the service models which are used by cloud. Now coming to the main discussion today, because I don't want to discuss much on deployment model and service model, because most of the things I hope are known to all of you, what are the advantages, disadvantages. So I think the better discussion we can have regarding everything is being now becoming a service. So we started long back service oriented architecture, which is a design method for applications, but now everything is becoming a service which is known as XaaS. So when we talk about XaaS, obviously we have the first three: software as a service, platform as a service, infrastructure as a service. Now desktop also as a service. So you can get an entire desktop from cloud. Communication as a service, you can communicate, right? So tools, functions, systems, everything can be delivered as services rather than standalone products. So this will enable, such type of concept enables the businesses to access cutting edge technologies without significant upfront investment. So now it is a shift from capital expenditure to operational expenditure. That means capex to opex for any business infrastructure spending. You don't need to think about capital expenditure now. Everything is becoming operational expenditure. So anything you say that can be given as a service. You can name anything. And like I have added two more just to show you how this can be extended: database as a service, monitoring as a service, disaster recovery as a service. Think about the new concept, even the disaster recovery. So you have some disaster, you want to be recovered from there, you faced some disaster, you want to be recovered from there, and that can also be deployed on cloud as a service, which can be accessed through the internet. Maybe using your mobile phone, you can access this type of services. So that is the new concept which is now changing the world, the changing the way we think, changing the way we uh, act also. Okay, so coming to our main discussion today: sensing as a service. What is why are we talking about sensing as a service? What is sensing as a service? First, what is sensing as a service? We collect, process, and sell sensor data and analyze across verticals to create new products, typically within real-time monitoring or predictive maintenance. So because we are now talking about IoT or cyber physical systems, again, it may not be possible for everyone to deploy sensors for their requirement. So sensors can sensors can be deployed by some service providers again, and there may be consumers who will actually consume services from such type of service providers. So who are actually offering say disaster recovery as a service can find sensors uh, deployed at many places, and those sensors will collect data, processed, and it will send some information to the consumers or users. Why do we need such type of services? Because this type of data or sensors will not serve one application. Rather, they will be shared and traded within the ecosystem of internet-enabled devices. You have some data, but you don't keep the data for your own consumption. You can use the data for providing services to others. So basically, it is like a marketplace where there are some producers who own the resources, just like cloud, and there are some consumers who are actually buying the services. So it is a kind of market. It is becoming a kind of marketplace. So it is a new business model. We have some people have the sensors. There are communication infrastructures, service providers platform, and there are customers. So uh, we can collect, share the data, and learn from the data using some kind of machine learning model or some kind of statistical model on cloud. this type of sharing and reusing can be free and or paid. See, when we collect from different types of producers,
Ma'am, your voice is not coming.
again,
Okay.
can you hear now?
Yes, ma'am.
Okay. So how long did you face this? Voice is not coming?
No, ma'am, there is no such issue.
ওদিকে problem, that side there may be some problem, right? Okay. So we can collect, share and learn from the data. Again, as we were discussing about cloud, it is a pay-per-use model. We can have participatory sensing because now the world is moving toward crowd sensing method. So crowd sensing or crowdsourcing, whatever you say, this is particularly related with sensed data. So we are using the term crowd sensing. We are sharing and reusing, which can be free or paid. So there will be reduction in data acquisition, and it is a sustainable business model. Suppose there are many cars, so all these cars can be fixed with sensors. In fact, when you use Google Map, Google is using such kind of crowd sensed data from different vehicles and using to show you whether there is traffic jam or congestion, whatever. So this kind of models are already there, but we are now talking about a business model. So we can collect data which was previously unavailable to us, and we can assist the scientific community or survey activities, okay, for survey and activities. So here is an example. Suppose we have, in a healthcare scenario, we have a doctor, management, and there may be other doctors as well, right? And there are patients. So we are gathering many clinical parameters from the patients, and there are many applications. This particular, this sensors are like SpO2 sensor, pulse sensor, temperature sensor, fixed way on the body of this particular patient, and temperature sensor, ECG sensor, pulse sensor deployed on the body of the patient too. Okay, and application one is monitoring the patient one for 1 hour. So application one will be taking all this data from 1, 2, 3 and monitoring this particular patient and sending the data to the doctor. On the other hand, this application, the second application, can actually take data from three is the temperature sensor, and here four is also a temperature sensor, and send the data to management. So management can actually monitor the temperature of all the patients who are admitted in the hospital. So this way we can think about several use cases. These are just very simple 2 use cases which we thought about in the healthcare domain. Like, for example, when we if we could monitor the heart rate of the patients who had severe problem in one of the hospitals in West Bengal only few days back, then we could if we could monitor heartbeat of all the patients admitted in that hospital, then probably we could understand that one patient or maybe three or four patients had the problem. So before they had the severe problem, we could discover and we could save some of them. So this is an unfortunate case which we had to face. But this is not a I'm just giving example for shared usage scenarios. But obviously, this is not a scenario where we can deploy the sensor, collect data, and sell the data. There may be other scenarios for such type of use cases. For those use cases, I am not talking about those use cases now. In healthcare scenario, we are actually talking about purely monitoring the patients on a regular basis, so that none of the problems that can be caused for the patient's health will go unnoticed. So that is our basic understanding. Okay. So how cloud can come into play here? See, this is an usual cloud environment where we have infrastructure, platform, and application. These are provided as infrastructure as a service, platform as a service, application as a service. On the other hand, presently we are using sensor networks. It's not that we are not using sensor network. Sensor networks are being used, and from sensors we are sending the data to the cloud, storing the data here, and getting the result to the base station or somewhere. Okay, it's already there. So what is the difference? General architecture of a cloud-centric IoT platform, which we are having presently, from the sensor node, the data goes to gateway nodes. From there, it goes to the cloud tier. So cloud tier, and then to the app tier. See, so the limitations are that these applications which are developed on top of cloud, they cannot handle heterogeneous sensor devices at this moment. There is also lack of standardization. There are different languages, protocols, and standards. So for each new upgradation changes, there is a requirement for changing applications. So applications need to be decoupled from underlying hardware components. It's not there now. In this particular application needs to know about all the sensor nodes. Otherwise, the cloud application will not be able to get the sensor data. I'm giving an example of ThinkSpeak, which is used for IoT projects. ThinkSpeak actually works with, now see, if you go to the website of ThinkSpeak, it says it works with MATLAB, Arduino, etc., with what type of sensors, features, everything is given here. So now see, if you have, instead of Arduino, if we want to connect another new ESP module, or say another new hardware, you won't be able to enhance ThinkSpeak for incorporation of that hardware unless you make some changes in the ThinkSpeak application. So that's the major hurdle of using sensors as part of cloud-based applications, cloud-based business applications. Because every time when you get new sensors, new hardware devices, new microcontrollers, you will have to change the application which you are running on top of cloud. So this is one major problem, major issue we are talking about. The other possibility is a pub-sub model, publish and subscribe model. So cloud can subscribe to the sensors, and sensors can publish and notify. So this happens like this. I'm sure. So there can be topic, message, and a publisher and a subscriber. So I can just show one example of this. There are several options. I'm not going to explain all these options because it is already 9 o'clock. So actually, in such type of cases, the sensor will advertise, and pub-sub engine will register in the sensor registry, and then the user will subscribe, and that request will go to the sensor registry. Sensor registry will then respond. So after it responds, the sensor node will publish, and then it will be notified to the user so that user can collect data. So this is one example. So pub So such type of pub sub engine can run for connecting cloud with the sensors. But there are limitations. So first of all, if we use a kind of pub sub model, consumer subscribes event notifications. So there are events and consumers subscribe those notifications. The middleware matches messages against subscriptions, checking the topic and delivers messages accordingly. So it is a topic based filtering. So if it is outside the topic, then consumer will not be able to subscribe. Subscribers, they do not know if there is a publisher publishing on a given topic. As I said, outside the topic, then you cannot access that. So suppose you want disaster, you want to know about flood, but flood is not subscribed. Instead of flood, earthquake has been subscribed. So you will never get any information about flood and how many of them there might be, or who the publisher of a given message might be. So subscriber doesn't know about all these things, all these details. Similarly, publisher, that means who is providing the service, does not know if there are any subscriber actually interested in messages on a certain topic. You have subscribed about earthquake, but no one is interested in the earthquake event because they are expecting that there will be no earthquake in a region. So no subscriber will be available at that time. Event-based data collection, that is one more problem. There is no continuous monitoring. So it is not suitable for continuous monitoring. Only when an event occurs, then only you can you will get messages. So the example which I have shown, healthcare monitoring cannot be done using such type of event-based data collection. Direct messaging between producer and consumer not allowed. It is prohibited by some applications, and also it is handled through the application layer, application specific. So the same problem. If we have new sensors, if we have new hardware, everything will have to be changed at the application level. So again, we propose virtualization for sensors as well. Likewise, we used virtualization for processors, storage, network, etc. In cloud. We propose virtualization for sensors as well, which will enable us to we will be able to isolate. Even fault isolation can be done. Encapsulation, so cleanly capture all VM state. Portability is possible, and also interposition and other characteristics. So whatever virtualization properties we heard about when we talked about cloud, all are possible now if we go for sensor virtualization. So what do we mean by sensor virtualization? Sensor virtualization means we are no longer considering sensor as some resources outside the cloud. Rather, sensors will be included as part of the cloud itself, right? So how do we do that? Sensor virtualization, what we what we mean by this. So requirements would be, what are the requirements we need to know? On-demand access to physical sensors, shared access to physical sensors, pervasiveness, elasticity, handling, and also handling heterogeneity. That is the main requirement, handling heterogeneity. On-demand access to physical sensors, shared access, pervasiveness, and elasticity, all must be there, all cloud properties. So users need not to worry about the real location and the differences of multiple physical sensors. Also, we think that the virtual sensors will be created in such a way that users will be able to use and control virtual function with standard functions. Like instead of writing special Arduino programs, or ESP32 programs, users will be able to write comments like read, write, etc., and will be able to access the data from the sensors. So read, create, something like that. And we should be able to dynamically group virtual sensors, and that could be provisioned automatically in response to the requests from users. For example, if I want the average temperature of Kolkata. So average temperature of Kolkata doesn't mean that somewhere the meteorological office has placed a sensor and we are getting data from there. No, rather all sensors, small sensor devices will be located everywhere in Kolkata, and we will gather data from all devices and we will average all the data and give the provide the result to the user. So when we get average of all this data, that means this is an accumulation of all the sensor data, right? So accordingly, we should be able to group the virtual sensors. And users can destroy their virtual sensors quickly when they become unnecessary. So it is just like virtual machines we talked about during the last lecture. Rather, instead of just CPU, GPU, storage, and network, we are now talking about sensors as well. So the definition we get from NIST actually. A virtual sensor is a software abstraction that allows sensor, in fact we modified the NIST definition, that allows sensor data streams from one or more heterogeneous types of sensors to be shared among different applications, either distinctly or in combined manner, with effective pre-processing as per the application requirements. Processing here, by processing involves, but by processing we may mean that filtering, aggregation, smoothing, analysis, etc. We categorize virtual sensors depending on their functions. So I'm not discussing, I'll give some examples later. And we considered such type of layered cloud architecture for accommodating our virtual sensors, where we have cloudlets deployed on edge devices, which will acquire data from the physical sensors and will convert to virtual sensors. So these virtual sensors can be created, the data can be aggregated, filtered, error handling can be done at this layer. Then we have another layer, which is the actual IaaS layer of the cloud which we know now. We will create virtual sensors here as well. These virtual sensors can be created, they will be able to aggregate, filter, and they will be able to manage the mobility as well at IaaS layer. At the higher layer, we will have allocation, deallocation of virtual sensors. So that means some physical sensors can be allocated to virtual sensors at this level, and the virtual sensor can be allocated again using the virtual sensor edge device level virtual sensors here. And similarly, we have defined some functions at pass level, and user applications will be running on top of pass. So this is the architecture which we proposed for our virtual sensors. There are other researchers who have discussed about virtual sensors. They have also talked about sensor cloud infrastructure, different types of service provisioning, etc. So these are for your references. So I will just briefly discuss resource modeling and allocation, because that is very different in case of sensing cloud or sensor cloud. Whatever we discussed regarding processors, memory, it would be different in some way. Okay. So how do we model the resources? See here, the objective is to treat the sensors as members of the generic resource family in cloud, like CPU and memory. So what do we have? In case of whenever we talk about resources, we have varying types of resources. Earlier we knew about CPU, memory, etc. Now we have temperature sensor, humidity sensor, blood pressure sensor, etc. The contexts are also different, because now when we are acquiring sensor for CPU memory, we had applications, programs, programming languages which are very much standardized. But here we don't yet have standardized, and it's not possible also, because blood pressure sensor cannot be used for environment monitoring. And even when we talk about temperature sensor, body temperature sensor will be different from atmospheric temperature sensor. So the context, we need to define the context: environment monitoring, healthcare. Also, the capabilities are different, because when we are talking about sensors, their sensitivity, transmission range, performance, etc., and even availability. Why did we include availability? Because we are talking about a business model. So every provider may not agree to provide services owned by him or her. Like, I have a GPS sensor, or and say uh, atmosphere pollution monitoring, like PM2.5 monitoring sensor fixed on my vehicle. But I want to provide services when I will exit from my house along with the vehicle and go through the road until I reach the office. So that may be from 9 o'clock in the morning to 10 o'clock in the morning. So rest of the day, I am not providing the service. But somebody else may provide the service from 10 o'clock to 11 o'clock and so on. So therefore, availability is also another issue here. These are the, we just defined 8-tuple for defining such type of resources, where we have kept category, type, CPU, memory, etc., state whether the resource is now down, free, provisioned, or ready. Contracts in those who have used cloud, you know there are different types of contracts when you use cloud resources. In some cases you can make advance reservation. In some cases you can make immediate reservation. That means on demand, you ask for some resources and cloud provider will immediately provide the resources to you. On the other hand, in case of advanced reservation, you will have to say that on 15th of January, I need these resources from 2 p.m. to 4 p.m. in the afternoon. So that is advanced reservation. Availability, I have already mentioned. Capability, like what is the, like in case of a process CPU, the capability can be the clock speed, number of cores, etc. Whereas in case of sensor, the capability can be different. What is the sensing capability, the range, etc. Similarly, context also, I already mentioned about context in the earlier slide. So what are the differences between computing and sensing resources? See, we are talking about creating virtual sensors for sensing resources, but that is not exactly same as the computing resources. Because when you for sensing resources, you can take resources from any sensing device. On the other hand, for computing resources, you cannot have CPU from one server and memory block from another server. That's not possible. So you will, when you ask for CPU and memory, the cloud provider actually schedule your task to the same server from where it takes the CPU as well as memory. Storage can be in some other places. That's possible, because now we can decouple storage resources from the servers. So that's possible. On the other hand, sensing resources, can be offered, sensing resources can be offered from different sensing devices. For example, I can use user A's car for measuring PM 2.5 and for atmospheric pollution. User B's car can be used for measuring the carbon dioxide in a particular location. So that's not possible. Therefore, that's possible actually. I'm sorry, that's possible. So therefore, we here defined a bucket to show, I mean, to demonstrate or to keep the resources which cannot be separated, like CPU and memory. So a bucket uh, keeps all the resources which cannot be separated. So there is a resource registry. A direct acyclic graph is constructed for denoting allocation and deallocation. Ages are moved from physical resource bucket to physical resources. Ages from virtual bucket to virtual resources. Ages from physical resources to virtual resources. So I'm showing an example. Say resource demand is given by type, contract, reservation, capability, and context. Okay, and reservation is here. Reservation means start time and duration is expressed. So in this case, we want to construct a virtual machine with one CPU, memory block 1, maybe 1 GB, a temperature sensor, a humidity sensor, a light sensor, and another temperature sensor and light sensor. So in this case, what we do, we from the physical machine 1, we take CPU and memory. From sensor device 1, we take these 3 sensors which will be created as a virtual sensor. Here this is virtual CPU and virtual memory and a virtual sensor. And from another device, maybe from another location, actually we are acquiring these 2 sensors, and that will be virtual sensor again, which will be provided to the virtual machine. So now this virtual machine consists of one virtual CPU, 1 GB virtual memory, one virtual sensor with these capabilities, and one virtual sensor with these sensing capabilities, maybe from another location. So this way we construct a virtual machine when we want to provide sensing as a service. So say I have already given example of average temperature. Say for example here, we have many temperature sensors located at this place, but we want service from any of the sensors. So this anyone taken from any of the sensor is named as selector. So we can create a selector virtual sensor for taking any one service. But in this case, for this person, many health sensors have been deployed on his body. So we will take all of them and then we will deliver as accumulator. So there are several such schemes. I'm not going into the details of this. So this virtual sensor will have capability of checking whether a particular measurement exceeds some threshold. If so, then it will send the information to the SaaS or PaaS services. So along with such type of resource model, because we are going to create a virtual machine, we have 2 different allocation schemes, the gathered and the scattered, for the same reason, because we cannot separate a memory from the CPU, memory block from a CPU in a particular server, but we can separate the sensors. Therefore, we have 2 types of allocations, gathered and scattered. In case of gathered allocation for computing resources to be located from the same bucket. So this gathered allocation will allow you to take the resources from the same bucket. So when you request for CPU and memory, the cloud provider will provide from the same bucket, and we will check the feasibility from the buckets only, minimize the number of buckets used. On the other hand, for scattered allocation, co-locality of resources not required, so you don't need to be confined within a bucket. So feasibility checking will be on resources. That means in the first case, we will check whether our server, if the user asks for 4 CPU and 8 GB memory, we will check whether our server has 4 free CPUs and 8 GB memory at this moment, so that that can be allocated to the new virtual machine, right? Whereas in case of scattered resources, we don't need to check with such type of server. We will check, okay, this temperature sensor is available at this site, so get it from there. Another light sensor is available from the same site, but may not be located on the same device. Therefore, we don't need to consider the device feasibility here. We will only consider whether the sensor can sense the data. So that means resource feasibility. I hope I could explain what do we mean by bucket feasibility and resource feasibility. So gathered and scattered allocations are designed for that purpose only. So I skip this. These were published in our in a journal and one conference. Some of the papers just listed here. Very briefly, I will talk about resource scheduling we considered for sensing resources, and then I will stop. Only I'm talking about these things just to give an idea how the cloud services models are getting changed and how we are considering to provide, or how the business people are considering to provide anything as a service. In case of resource scheduling, similarly, we faced several challenges. For example, as I said, challenge one, a single resource may not be available for the entire duration. Capabilities vary depending on resource type. Say, for example, a temperature sensor has 0 to 100 degree sensitivity. So we are not going to use such type of sensor for measuring the atmospheric temperature, because uh, for atmospheric temperature sensing, we will not go up to 100 degree. Therefore, it is not required, right? So we need to understand the capability of the sensing device. Performance can also vary. So by performance, we mean throughput. So we have carried out an experiment uh, while moving on a car, and checked the throughput from a temperature sensor, atmospheric temperature sensor, and found the throughput actually varies based on connection and many other things, many other particular characteristic of the environment. Okay, therefore, this scheduling problem needs to be modeled as a graph traversal model problem. Each performance partition, we have the performance partitions here, shown here. Each performance partition is represented as a vertex, and because they are not available all the time and we are trying to get the best performance, so we can hop from one partition to another, which will be represented as an edge. Objective is to compute a continuous path which will start from one partition, and um, it will move to another partition and then move to another partition. The partitions may be overlapping, and until the request time ends, it will move from one partition to another partition. That means we need to have so many sensors available uh, throughout the request time. So what we modeled are shown here. Basically, these are three different sensors with two requests you can see that actually these are the partitions. So one request can, at the end of this partition, it moves to another um, device, and then from here it moves to, it goes on doing like this and then moves to another device. So it goes like this. These edges are actually when we, how we provide services from one sensor to another sensor, the edges show demonstrate that particular um, service provision of services. Okay, and there are different selection criteria, like based on feasibility, appropriateness, load balancing. We have decided how to select among various service providers. So all sensors are now service providers. So the problem is actually NP hard. We have applied integer linear programming problems to solve this, okay, with the objective to minimize the cost and maximize the performance. Obviously, every time the problem is not so hard, and in fact we could find, we could also find some approximate solution if we didn't want to minimize the cost and maximize the performance. We could actually check only the availability, and based on that we could provide the services to the users. So these are all regarding resource scheduling. I'm not going to discuss the in detail. You can always get the papers to see whatever was done. And I skipped this part. Just these are regarding availability of mobile resources. So coming to the conclusion, cloud can offer different types of services to the users, and it can open up new business models. However, there are many challenges like handling heterogeneity, resource allocation, scheduling, shared access, mobility, and error handling. And in fact, during today's discussion, we have used only sense, we have talked about only sensing as a service. But if you have other things as a service, like disaster recovery as a service, you will have to consider many more things which are not being considered at this moment. So whenever any kind of services are provided on top of cloud, every uh, provider needs to consider several things, and needs to consider several issues, several needs to face several challenges for getting a solution. Okay, and so each type of services need to be handled with necessary approaches. With this, I would like to conclude today's discussion. I believe that I have concluded exactly in time. So if you have any uh, questions, I will be able to answer. Thank you.
Thank you, ma'am, for this wonderful session. We have reached the time limit of today, but still we'd like to address the questions from the participants. So participants, do you have any question to ask, ma'am?
I think now it is almost 9:30.
9:30.
So no one is interested now. But if you have questions, you can always write to me.
Just a minute.
If you have questions, then obviously.
Prabhu D.
Okay. Yeah.
Madam, good evening, madam. I
Yes.
don't have questions, but I would like to just provide my feedback on the session, madam. The session was highly interesting, madam.
Sorry?
Hello. The session,
Yes.
the session was highly interesting and informative, madam. One small doubt I have, madam. Can I ask now, madam?
Yes, sure.
Posting this, we have this issue, madam. I don't know whether this is the right forum to ask. We try to make a e-services portal, madam, and we want to try to check the virtual load Actually, that 1,000 requests are happening at the parallelly at the same time, madam. But we were not aware how to make that at that time. We hosted the e-services portal in a virtual machine, madam, in a Linux server. It was provided by VirtualBox, madam. This Oracle VirtualBox. How to
Oh, you
generate
could
this
not-
load?
So what is the problem? You could not use the 1,000 requests at a time. You could not.
Yes, madam. We could not generate 1,000 requests, madam. Virtual request. Virtual machine we hosted and we checked, madam.
Huh?
Is there any possibility where we can generate the load also virtually, madam?
Probably it can be the limitation of the cloud provider where you could not do that, because you see at the end of the day they are that is what I, in fact, not directly related to your problem, but I just wanted to say that, because at the end of the day everything is not in your hand. The cloud providers, whatever they are giving, that is you need to be happy with. Okay, so I think hearing your problem, I think it may be due to the limitation of the cloud provider, but obviously you can send if I have I don't know whether I have rightly understood, but if you can send your problem, you can mail your problem to us so that we can check and let you know. Shall I give you the email address? Can you
But
see?
I will submit.
Can you see the email address?
No, madam.
No, it's not.
Can I collect the coordinator, madam?
Yeah, I think you can collect this. But for some reason, I cannot use the chat. I don't know why.
Okay, madam. Okay, madam.
Can't you see the now the screen? Oh no, sorry. I'm not sharing this one. I'm sorry. I'm sharing this one. So yes, here probably I should be able to write. Write your problem with more details so that we can respond to you. Okay.
Surely, madam. Surely, madam.
Any other question? So if there is no other question, then I can stop here. Thank you very much for listening for 3 hours almost.
Thank you, ma'am, for this wonderful presentation. It's a privilege to hear from you. Okay, so we are ending the session now. We'll be sharing the feedback link and the WhatsApp group. Participants, please follow that group. We are sharing this one. Thank you, ma'am. Thanks a lot.
Thank you. Thank you very much. I'm leaving now.
Thank you, madam.
Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Hello.
Thank you, ma'am.